Hello, ladies and gentlemen. So today I want to talk about a project that I finally got done over the school year. So what I want to talk about today was the useless machine that I made. And so I got it right here, so I'll probably be pointing and just flailing around on this thing for a while. This is what I've been working on for a good part of the school year. I started out on this project back last fall, probably around like September. And I wanted to set out just to make something kind of like those old useless machines they made. And those ones all normally had like one button or kind of a gimmick. So my spin on this was that I was going to have a bunch of different buttons and switches on the top so you could have different ones and it would be more interesting to program and interface on the top side of it. So I worked on this with a friend, Tyler, over the school year. Me and him started working on this, like I said, last fall. And it was really fun. A lot of the fall semester was spent on working on the robot arm, and a lot of this for me was working on redesigning the 3D printed parts from my last project and beefing up the servos to make it a lot stronger, because over the last two projects I had those little micro servos. They were just way too weak for what I wanted, and I was just driving way too much weight on them, so it didn't really work out like I wanted to. But this guy did pretty good. I was really happy with how the individual arm worked. I'll probably just layer some video over this, maybe right here, we'll just do that. We'll point for today. But yeah, so pretty much the fall semester was on designing the robot arm and thinking, okay, well, how's it going to come out of the box? And so then we ended up adding these two other servos on the top that their sole job was to open this kind of flap or this window right here, and you can kind of see it's got the glass on it. But yeah, and so that worked out pretty well. We were just thinking about like how to do that, brainstorming like before the semester ended. And then over Christmas break, my friend Tyler, he worked on making this wooden box, and then it has kind of like a glass case on it, which I thought that would be cool because it'd be kind of like a PC case where you kind of like see what's going on the inside, because when you hit the switches and the robot moves, it's really interesting to just kind of see how it moves on the inside, because with this robot arm, like there's a lot going on there. And I think it just really wouldn't do it justice if you couldn't see it. And I know some point of the actual like robot arm is that, you don't see what's inside and it just like does a little like movement on the outside, but I think this is cooler just for like this project. But yeah, and so we were kind of working on that over break. After break, we got the box, and the first thing we did was try and get the servos to move. I know I have some videos of that, so you can see that over here this time. Yeah, so I'll stand here for a minute. Then we decided to have like a plate on the top, and I 3D printed that. We wanted to try and 3D print the box, but it was just too big for the Ender 3 to handle. It's right behind here. Just because the base of the bed, it wasn't long enough to cover this kind of whole like base of the box right here, so it was just way too long. But I'm really happy with how this turned out. It like fit perfectly for what we needed. I didn't have to like change any of the dimensions of the robot arm. And speaking of robot arm, we did do some changes to it in the middle of the school year, kind of over break again, because the initial parts that I had were in that kind of like black gray filament that I had normally. But then I bought some red stuff because I thought it'd go with kind of like ISU colors better. But then I changed up some of the dimensions on the top robot arm because the actual like hand on it, it's like a Lego hand, but it was like about as wide as like maybe 3 of the switches across on this top board. And it would just be a mess to try and like actually only hit one of them. So I made it a lot slimmer, but it was a pretty easy fix. But yeah, then I ended up just reprinting all the other parts. I just kind of had some slight improvements on each of them. Like for example, the bottom base part, the part where the servo mounted to, it was just this thin little like plastic piece that went up. It snapped off, and since it was 3D printed on, I had to reprint that whole 12-hour print just because that broke. So then I ended up making those 2 pieces with screw holes in them. So if it broke again and we needed another one, I would only have to print another like smaller piece of it for like half an hour. And really glad I did that because it ended up working out pretty well. But yeah, so then as second semester was rolling around over break, kind of like last fall, I learned how to do some like PCB design. So I designed like a super simple board with a picture of it right there. Look at that. Magic. And so what I did was I just had like push buttons, tactile switches, slide switches, and just a couple different inputs so you got that variety like I talked about earlier. And so then what I did is I just had a 8-pin header 4x2 thing, and then another 2 pins with like little screw terminals to get power to the board. And then so they had those 8 digital pins on the top, and then those went into the Arduino near the bottom. And you can see that by right in here. And so There's the Arduino and a servo motor driver, which just makes it super easy to code and interface. Really, really easy on the code side of this thing. There really wasn't too much coding until the end when we put it all together. Because before that, I was just interfacing like different servos for the robot arm and calibrating that, we got that going. But there was kind of a lot when we ended up putting it together at the end, but not too bad overall. Definitely something in my wheelhouse. But yeah. Then we got 2 power supplies. On the front, we got 4 AA batteries and a 9-volt battery. 9-volt battery goes into the Arduino, and the 4 AA's power the servos because you want 2 separate power supplies. I know I've talked about that before, so I won't get into it again. Yeah, really on the board, all it is just pull down resistors for all the buttons so that they're logic level low or 0 normally. And then when they're pressed down or flipped towards the robot, they go to a 1. And I'm really happy with how that was. I really wish I put indicator LEDs on at least like the power and like, I mean, the buttons you don't really need as much, but like the switches just to know if they're actually on or off, because before we had the code fully working, it was kind of hard to know without having an Arduino plugged in to like a serial to actually get that data. I like being able to do that with hardware because did that with another board I've been working on recently. That'll probably be a future video, and it was just really nice to be able to check it and probe it instead of doing all the other stuff. But yeah, there wasn't too much else to it. I mean, just checking for, it was kind of tedious going through because we had to hard code different movements for each of the separate buttons as it kind of like sweeps across this like front board part, but it wasn't like too bad because once we got down like maybe like 2 or 3 of them, pretty similar code in between them, and kind of like the spider robot I did with the servo movements, you kind of could see like some patterns in it, and that definitely made it easier. But yeah, I mean, I definitely like using the larger servo motors. I think that was a huge bump to this project, especially with the robot arm. I don't think it would have been strong enough with the micros. I mean, we definitely could have scaled it down and made it smaller, but I really like the size of it. I like that it's a little bigger in scale than my other stuff. Really glad Tyler could help out with the box and help out with coding. That's a huge help. But yeah, on the code side of it, it really isn't much. Really just, like I said, these 8 digital data pins go into the Arduino as either 0s or 1s, and if they're 1s, then a function that reads the buttons will return which button went to 1. And so it reads left to right. So the priority goes to this leftmost push button first, and then this tactile switch, and then this slide switch, and so on. But what happens is if 2 are pressed, it'll just like take the 1 on the left, but that button, like this leftmost button is 1, 2, 3, 4, and so on. And if no buttons are pressed, then it returns 0. Because when the robot arm comes out, it's the same for all the buttons because it just kind of like comes up into that state, and it also goes back in the same way. So we reused a lot of code there, and then whenever the robot arm was like out, we had code that defined like where it would turn, how far it would go up or down to like select it. And that was, like I said, just a lot of testing and small trial and error stuff. And if we changed the angle too much, it would just like slam into the board here and this like printed mounting plate we did. And I was always worried I was just gonna keep breaking something, but we did that a bunch of times accidentally. Also, one thing, if you turn off the Arduino before you do the servo driver, the servos don't like that because they don't know what data's going into it, and they'll start like just like turning one way, and it would like crumple the robot up. And at this point, when everything was like finalized and put together, that was a nightmare. That scared me that was going to happen, so I was always really careful with that to doing those on, but definitely got to remember that if I pull this thing out in about a month. I mean, there isn't too much with it. I'm really happy with how it went. Kind of took a while, kind of just did this in multiple parts. We were waiting on getting this like PCB I designed and our kind of second wave of parts just with that board for like maybe a month or 2 in the spring semester, but also just like school has been really just slowing down these projects, but that's kind of to be expected. But yeah, I don't know how much of this I'm going to keep in or cut out, but we'll see. I mean, I wish I got more video of this stuff. I guess that's the only other thing. I didn't really have time to like set up and record like the soldering or the 3D printing time-lapse stuff, just because I was very rushed to even get this done just with school and stuff. I just wanted to see this thing through this school year, but hopefully for future videos I can record a little more throughout the whole process, because that's something I did want to get more into. But I still do have a lot of videos of doing the CAD for this and the PCB design, so hopefully that'll give you a pretty good idea. And I'll still include like videos of this thing up close and layer this. Probably got them like bouncing between me anyways. Who knows what I'll decide when I edit this. I don't know. But yeah, if you're interested in my stuff, feel free to just look at my other videos. I feel like I've been trying to just try something new in each of them. I really like editing and like layering stuff over myself talking. and really just like, you know, showing all my stuff off. It's fun. I got a few other things in the works right now. Hopefully I'll be able to like get videos of them soon. Not fully sure just with time. Probably when the summer rolls around, I'll probably catch up to myself and like get all these things finished up. Because, you know, it comes back to the problem. I got so many ideas, but just not that much time. I think a lot of people could agree on that right now. But yeah, thank you so much for watching. Hopefully I'll come out something soon again. But see you in the next one.